Okay, welcome to the Unit 2 Lesson 6 video, which will cover the discriminant and analyzing solutions. So this video will explore the discriminant and talk a little bit about how that can be useful and when we're analyzing different types of functions, quadratic functions particularly. So first we'll talk a little bit about the discriminant, which will provide you with certain characteristics of the function in its graph. It's part of the quadratic formula. So if you remember, the quadratic formula is x equals the opposite of b plus or minus, and then we have this part under the radical sign, which is b squared minus 4ac, and then all of that is over 2a, and that's the quadratic formula. So this part here that I wrote in the purple is the discriminant, the b squared minus 4ac. That is the discriminant, and that's what we're going to be using to explore and talk about as we look at these different quadratic functions. Alright, so we're going to look at the value of the discriminant. So we're going to look and see what happens when the b squared minus 4ac is greater than 0. So when it's greater than 0, we'll say that the discriminant is positive. So when the discriminant is positive, the b squared minus 4ac will be greater than the value 0. So when that's true, we will have two real solutions. Alright, and what that would look like on the graph is something like this. Now, the discriminant being positive does not mean that the function opens up. It could open down. It doesn't mean that my zeros are negative or positive, or that they're one or the other or both. What it means is just that it will have two x-intercepts. It will cross in two places. These are my two real solutions. Where it crosses could be anywhere. They could both be negative. They could both be positive. One could be negative. One could be positive. It could open up. It could open down. All the discriminant tells me when it's greater than 0 is that there are two real solutions. Now we can look at our next possibility here, which is that b squared minus 4ac is equal to 0, right? And we'll say the discriminant is 0 in this case. And in that case, there will only be one real solution. Now that solution, right, that one real solution has a multiplicity of 2. Sorry, that's of 2. And don't worry too much about what that means. We'll explore that more later, but just to kind of introduce you to this idea of multiplicity of 2. So what does that look like on a graph? Well, again, it means that there will be one x-intercept right there. Or, again, it could be going up, it could be going down. I don't know. All I know is that it will touch the axis in one place. And it could be positive, it could be negative where it crosses, but it will come down and bounce off of the x-axis. And that's one real solution. And of course now our third possibility here is that our b squared minus 4ac is less than 0. In that case, we would say this is a negative discriminant, and a negative discriminant will have 0 real solutions. However, it will have two imaginary solutions. So, two imaginary solutions, that's kind of what you need to know at this point, right? We'll get into what an imaginary solution is in a future class, and that involves the number I. But again, all of that will be explained later. For right now, all you need to know is that when b squared minus 4ac is less than 0, you will have a negative discriminant, which will mean you have two imaginary solutions. Since a solution is where the graph crosses the x-axis, if we don't have any real solutions, we only have imaginary solutions, well then our graph will not cross the x-axis. So to look something like that, or something like this, either way, there is no x-intercept. It's either above the axis going up, or below the axis going down. Either way, there are two imaginary solutions. So let's take a look at doing a couple problems where we'll actually find the discriminant. So again, what's important here is that it's ax squared plus bx plus c equal to 0. So if this function is not equal to 0 in this format, then I can't find the discriminant. So the first thing here is to bring that 6x over, bring that 5 over, and set it equal to 0. Now that I have it in standard form equal to 0, I can then do b squared, which is negative 6 squared minus 4 times a times c. And then let's just see what happens here. So that gives me 36. And this is negative 4 times negative 5, which is positive 20. So I end up with 56, which is positive. And so this is a positive discriminant. So I have two real solutions. Okay, so let's just try one more here. And again, this has to be equal to 0. So let's set it equal to 0 and say 2x squared minus 3x plus 7 equals 0. Then we'll set it up here. Negative 3 squared minus 4 times 2 times 7. And we'll get 9 minus, that's 8 times 7, which is 56. So 9 minus 56 gives me a negative 47. So that means I have a negative discriminant, which means I have two imaginary solutions. Okay, so why don't you go ahead and try this last problem and see what you can do, and pause the video. I'll work it out while you work it out, and then when you unpause the video, you'll see the solution. Alright, so pause the video. Okay, so you should end up with negative 20, meaning you have a negative discriminant with two imaginary solutions. Now notice I had brought the 3x squared over by adding. If you had happened to take over the 4x over and then the 3 over, you should still end up with a negative 20. That shouldn't affect your discriminant. You should still end up with a negative discriminant and two imaginary solutions. So you got a little bit of flexibility about where you want to take the terms. As long as you get all the terms to one side equals 0, you shouldn't have any issue with getting the correct discriminant, as long as you're following the correct formula. Alright, so let's take a look now at the next page and talk a little bit about analyzing functions. So given the equation in different forms, describe the discriminant and how many solutions the function has. So you should notice that this is in vertex form. So in vertex form, it tells us the vertex, right? So I have a vertex at 3, 0, because I'm adding nothing. And it is a going down, right? This is a max value, right? So because the vertex is on the x-axis, I know I only have one real solution, right? Anytime the vertex is on the x-axis, there'll only be one real solution, which means my discriminant has to be 0. Now you could work this all out in the standard form and then find the discriminant, but if you understand that this is vertex form and the shape of the graph, there's not a need, right? So go ahead and try this one. See if you can figure out, again, this is in vertex form, right? So see if you can figure out the vertex, if it's a max or min, and the number of real solutions. So pause the video and try this first problem. Okay, so again, this was in vertex form. Because nothing is moving laterally, horizontally with the x, it's 0, -2 is my vertex. That is a max vertex because it's been reflected. So it's going to look something like this, right? And if it's going down and the vertex is already below the x-axis, it's not ever going to cross. It's going to have a 0 real solutions, and it will be a negative discriminant. All right, so let's take a look at this last problem here. So you should notice that this is in intercept form. So when you have a function in intercept form, they're telling you where it crosses the x-axis. So if it's in intercept form, there's has to be 2 real solutions because they're giving them to you, which means that the discriminant has to be positive. Okay, and then we'll do one more here where they give you an actual graph, and you should be able to tell me that this discriminant is negative because there are 0 real solutions. This graph does not cross the x-axis at all, meaning the discriminant is negative with 0 real solutions and 2 imaginary. And never mind my spelling, 2 imaginary solutions. Alright, the last little bit we're going to do here is finding values and how they affect the discriminant. So in this equation, I don't know the b value. So what it's asking me to do is find the value of b that will make the discriminant positive. So if my equation is b squared minus 4ac and I want it to be positive, then it has to be greater than 0. So now I can plug in the values that I do have, and make it greater than 0, and then solve for b. So that's b squared minus 8 times 12 is 96, greater than 0, so b squared has to be greater than 96. So when I take the square root of both of those sides, and here's where it gets a little tricky. So b has to be greater than square root of 96, which is 16 times 6. So that's 4 root 6. B has to be greater than 4 root 6, but it also has to be, there's a plus minus here. So again, with inequalities, you have to flip the sign when you make it negative. So values of b that will make the discriminant positive is when b is greater than 4 root 6, or when b is less than negative 4 root 6. So those are all the values that will make this discriminant positive thus giving me two real solutions. The other way this could be asked is find the value of C that will produce two imaginary solutions. So it doesn't tell me if it wants it positive or negative. It tells me imaginary. So that means I have to realize that b squared minus 4ac must be less than 0 to get imaginary solutions. So again, we're just going to plug in the values I have, which is negative 4 squared minus 4 times a times c, and make that less than 0. So I get 16 minus plus 12c less than 0. So let's get rid of this 16. So divide both sides by 12. And then I get when c is less than negative 4/3. So there's no plus minus here because I did not take the square root of a variable. So any c value that is less than 4/3 will give me a negative discriminant, which in turn will give me two imaginary solutions. So again, all you need to do when given questions like this is set up the equation with the correct less than 0, greater than 0, or equal to 0, plug in the values you have for either a, b, or c, and solve for the variable you need. Just keep in mind that if it is b that you're solving for, you need to take account for the positive or the negative value, and don't forget to switch the sign if it's an inequality. If it's an equal sign, you don't need to worry about that, but if it is greater than or less than, you do need to switch it when you take the negative value. Alright, and that's the video for the discriminant. If you have any questions, we will talk more about it in class. Have a good day.